Cron is a system within Linux that allows you to schedule periodic jobs that happen. And it's generally used for system administration, like cleaning up log files and making sure that systems stay healthy. But it's often used by attackers to establish persistence. So it's generally seen as, making calls over the network to download malware, to execute some malicious payload that could be stored even in DNS records, as the second example shows, or could just be starting a netcat listener to give an attacker remote access into the system. To detect this type of behavior, what we'll do is use a tool called osquery. And for those unfamiliar, osquery is an open source project developed by Facebook that expresses the operating system as a set of SQL tables. And this specific query that we're looking at is the select all from cron tab query, which will tell us if our system has any of these crons set up, and then it will give us some attributes around that cron, such as how often does it run, which user created it, things like that. The pipeline to get this data out of osquery looks a little bit like this. And for those who are familiar with osquery, there's a lot of ways to slice and dice this. osquery has this plugin called AWS Firehose, which was actually developed during my time at Airbnb by Airbnb. And we used it to write out logs directly to Firehose, which is a message bus in Amazon that allows you to bulk write data to some data store like S3. So all of our nodes can write these logs to S3, and then you can connect those buckets to Panther using our UI, and then you can start reading the data from your nodes directly. So this is actually a built-in rule that we have that's open source. And as you can see, it's much more complex than the first one that we wrote. So let's break down each individual piece. So we're importing some standard libraries at the top, FN match, which is helpful for pattern matching. So if you want to do glob-based or just file-based pattern matching, you can use FN match. You can also use regular expressions if that's what you prefer. Again, this is one of the huge benefits of Python, is you can really do whatever you're used to. We're also importing a library called shlex, which allows us to parse out individual command arguments. And this is especially helpful when you're looking at cron. So what we're doing is we're actually declaring, like, what are our suspicious cron commands that we care about? So we're looking at, things like curl and dig and netcat and wget, and these things that normally wouldn't be in cron jobs. And then we're also looking at arguments to these commands. So we can say, if someone's piping the output of a wget command into bin sh, then that clearly looks like someone trying to establish persistence. And then what we have, again, this is our rule function. We're taking in one argument of event, and we're doing some logic to determine, one, that we're looking at the right osquery data, and then two, that we have the right fields in the event to actually do the analysis. And then finally, what we're doing is we're saying if either a suspicious command exists in the cron or there's a suspicious argument in this cron, then we want to fire an alert. And then again, under that, we have our deduplication period, which is looking at the host. You could dedupe based off of the specific cron command if you wanted to, or you could actually leave this blank and it would just dedupe based off of the title. So if we have our system all instrumented and set up, we do cron tab-l, and then we see there's two existing crons. One of them is a wget. The other one is an S3 sync. The S3 sync doesn't match any of our rules, so that one wouldn't fire, but the second one would. So then what we see in Panther, we get our Slack alert as we normally would, or our PagerDuty or whatever we have configured. Then, we click into the browser, we see a suspicious cron found from this IP, which if we go back, we can see that's exactly what we interpolated in our title function. And then we get some other information. So we get a quick runbook, which is look at the command, analyze it, make sure that, it's actually bad and not something legitimate that our ops team is doing, which sometimes happens. And then we can see our deduplication string that was interpolated. So this is the actual host that we care about. And then we see the exact command that was shown in the first screenshot, which is this wget to, some place. This is just Google. Obviously, Google is not malicious. Their slogans don't be evil, so we can ignore that one. And then we see the path where this cron exists. So Ubuntu, so this is the root user of the system. So if this was actually W getting something malicious, this would be a really serious finding. And then again, what we can do is we can click through to our data explorer, and we actually get a query that's crafted already for you, which you can change. You can filter it for specific fields. I'm looking at the calendar time, the host ID, and then some information about the cron. This is really helpful if you have hundreds of hits on an alert, because you don't want to necessarily just like click through all of them individually. You want to be able to write SQL on top of these events and extract some more insights, statistics, things like that. And yeah, that's essentially it. I mean, that's